let's sketch each function with these, without the assistive technology and identify any restrictions. Benito, what did you do first? Factored it. Okay. When you factor, what do you get? Raise your hand if you got that when you factored it. Just using your x method, and then you still have an x plus 2. But alright, what do we do from here, Carla? The removable whole? Correct? Cancel those out. What do I write in this orange box? Good. So if I have a graph at that point, it's going to be a removable whole. Trisha? What did you do next? The what? The vertical asymptote? Okay. Good. Remember, the common mistake here is to think that what we did not cancel is just x plus 2. But class, where is the x plus 2? On the bottom, the denominator. So you have to put a 1 here. That's super helpful. And so Trisha recognized that the x plus 2, this is the denominator. That's how she got this one. And Trisha, your answer? X is not equals -2. Thank you. Nathan? Yes. Let's do the horizontal asymptote. Let me give the class some tips, but this might be helpful. The values if you look at the original or the new. But I would probably look at the new one because it's like a little bit simpler than that one. Okay, Nathan. Where do you want to look? The original or the new? Okay, what is the top degree here? So if I put a variable here, what number would I have to put on the top? So it is a 1x, but this would be a 0. So your top degree would be a 0. And what's your bottom degree, Nathan? Okay, what's the degree of the variable? There's no number there, so you're going to choose a 0 or a 1. Okay, the answer is going to be a 1. So a big idea we're learning in this chapter is just a review of exponents. X to the 0 power is 1. And if there's no number, that's a 1. Peter, what inequality can you put in there? One is greater than 0, so you're going this direction, and we read that as 0 is less than 1. What's your result? Yeah, less than y equals 0. Okay. So this is what we've been doing for the past couple weeks. Now we're just going to add those to our graph. Let's do my horizontal asymptote y equals 0. Everyone show me a horizontal line with your arm. So let's go ahead and draw it. And then I have a vertical asymptote at -2. And then I have a removable hull at also -2. Now, you'll see later on, if you have a removable and a vertical asymptote at the same places, class, can the graph cross there at -2? No. Which means that your hull's not going to exist. So we'll just color it in. Okay, we factored, cancel, set the denominator equals 0. We got the horizontal asymptote. Now we're going to make our table of values. Okay, super important, what is in the middle of the table of values? And I have Roberto to tell us. What's in the middle of your table? What is your vertical asymptote? He can do it. So your vertical asymptote here is at -2. This separates your graph, left side and the right side. So that is going to be the middle of your graph. Highlight that. This is the most important number to think of because we need 2 numbers to the left and then 2 numbers to the right. Roberto, by yourself, pick 2 numbers to the left of -2. And? Yep. Pick 2 numbers to the right. Jasmine, can you pick one of these numbers down here for me to do step by step, and then I'll let you guys do the rest.
4.
-4?
Yeah.
Alright. So remember, you can pick the original. This looks pretty complicated because there's lots of x's, or the original. Before I added the 1 and 0, we just had 1 over x plus 2. So I'm going to use that, 1 over x plus 2. And what the table of values is just you take these numbers and you substitute it in. Our x value is -4. And then class -4 plus 2. And 1 divided by 2 is a decimal. $1 divided by 2 people, 50 cents each, so -0.5. Let me show you how to get that on a calculator. So if you're doing -4, I have a Texas Instrument here, so I'm going to type in -4 plus 2. That gives me the -2. And then sometimes in your calculators you have a 1 over x. This calculator does not have it. So I'm going to press 1 divided by -2. And that gives me -0.5. Remember, if you wanted to go f to d or d to f on, that goes from fraction to decimal. And you just press the equal sign and it keeps going back. Okay? Alright, when I say the word go, one person's going to explain all of the boxes. And the other person's going to explain the table and how I got that. And then you guys will finish the table. I'll give you guys 4 more minutes. And then I'll be calling on students to get me more answers. Yeah, it's 0.5. So with my table then, all these numbers, right? If I want to look at -2, it says error. That's our undefined. If I do 2, my answer is 0.25. Okay? Let's go ahead and graph it. What you want to notice is to the left and to the right are the numbers going to be positive or negative. So -4. I have -0.5. I think of money, this is like 50 cents. 50 cents negative is not -$2. It's not -1, but it's -0.5. What is important is that you're comparing these two numbers. Class, what's more money? 0.5 or 1? $1. So -3 is further out. That's what's more important. Even though I should have put it like that one should be up here. So this is further. This is more. So this is more negative. And then I go on this side. 0 at 0.5. So 0 and 50 cents. It's not $2. It's not half of $2 is 1. But it's closer to $0. And class, which one is more, 50 cents or 25 cents? Which means that this is lower. That's closer to 0. That's what's most important. So these are negative numbers. They're down here. These are positive numbers above. And your last tip to show that this was correct. X to the first power is an odd. Remember, odds are separate. They're opposites of one another. If it was an even, you might think that's an even, but this right here, the new one, tells us the most information. They're not a volcano. They're opposites.